So first thing first, review test 2 is coming up Monday and Wednesday. So class, make sure what day you show up. And last name site N2Z is on Monday. Last name A to M is Wednesday. The time is from 12 to 1:30. It's in CIA 114. It does cover chapter 7.4 and 7.5. And then the whole chapter 8, except for 8.5. Don't forget 7.5 formula will be provided in this test, so you do not need to memorize your formulas. And also you're allowed to use 1 page of notes. You can bring 1 page of notes into this test too. And it's just only the front page, not the front and back page. As I mentioned early on, the review test 2 is do your review test 2 because it's mandatory. It will contribute 10 points to your test 2 as non-SNSL credit, means that it is a part of your test 2. When do you submit your test 2 is when you do your test. You just submit in person, staple your review test 2 together, and then you just submit to me. Make sure you have your name on your review test 2. If you don't write your name, I just trash it because I don't know who the person is. So that's important. As I mentioned also, when you do your review test 2, you should be able to do all the questions now. The only questions that you cannot do is question 10, because that is the last section that we go over in today's class. Anyone have any questions about the test 2 here? All right, we do have a questions on 8.4. This is question number 10. So this question 10 is asking us to figure out, use the vector u and vector v and vector w given in this component form, figure out what is v dot 0, this is 0, times w. So what we do here is follow the orders of operations. We're gonna do the inside the parentheses first. So we take the vector v, which is -3, 1. And then we dot it with 0. Now 0, the vector 0 in this case is 0, 0. Okay, this is the vector 0. So this will give us 0. Okay, because -3 times 0 is 0, plus 1 plus 0 is 0. But you have to multiply this with vector w. So vector w in this case will be 3 and -2. Okay, so when you you distribute this you will get 0, 0. So in this case, this 0, 0 can be also written down as 0. So your answer in this case is 0 or 0, 0. So what is the result? So this is the main part is, since you get this 0, 0, so this is actually a vector form, okay, not a scalar form. So your answer in this case, the result of this case will be in a vector form. So your answer in this case will be 0, 0. And this is going to be in a vector form. So make sure you guys understand this, that when you have a dot product, the dot product will give us a scalar. And then when you multiply the scalar with a vector, you will still end up with a vector form. Okay, so this is how we do question number 10. For this is 8.4. Okay, so this is section 8.4. Question number 10. So this is how we do this one. Anyone have any homework questions for me? The reason why is because chapter 8.3 and 8.4 is due tonight. Okay, so make sure you guys do this. So 8.3 and 8.4, your online homework is due tonight. You got one more section on tonight. 8.6, we will skip 8.5. We will not doing 8.5. We will do 8.6. 8.6 online homework is due on Sunday by midnight. This Sunday, I think is what's the date for this Sunday? The 12th, the 14th. Okay, So you got one homework due on this Sunday that is due by midnight, which is 8.6, and you got two homework due by midnight tonight, which is 8.3 and 8.4. Then you will have your second test on Monday or Wednesday, depends on your last name. Questions? Okay. Now, I know I have a little bit left in 8.4 that I did not do. The one of them is the what we call as the projection. So projection V onto U. So we do. If I have time today, I will go over this and also how about force. Okay. So these are the few questions that it's not going to be in your test too. That's the reason why that I do not want to spend a bit more time here, because make sure if I have time today, I will definitely teach you the projection U onto V, and also how you figure out the force of word problems. So these are a few questions in your online homework that talk about the force here. They all have a watch it button here. So I would recommend you guys, if you start with this, please do watch it. The reason why we didn't go over this is because of it's not in your test. We want to concentrate more on your test, and you're going to concentrate more actually on 8.6 because that is the one that we will be concentrate on here. So let's talk about 8.6 now. So in 8.6, this will be talking about trigonometric form of a complex number. So this 8.6 has nothing to do with vectors. Okay, so again, 8.1 and 8.2, we do law of sine and law of cosine. Then 8.3 and 8.4, we talk about vectors. So again, law of sine, law of cosine is nothing to do with vectors, a little bit, but they are like not very it's not kind of the same. And then the 8.6 we're doing here is a complex number, trigonometric form in a complex number. So the first thing we're going to talk about here is your complex plane. So every time when you draw a complex plane, so last time when you do your real plane, it's not complex, this is real plane. A real plane in this case is what we call as your coordinates plane. So in a real plane, we will have X and Y. And if you want to do a third dimension, then you will have the Z dimension came out in this case. So it's like so if you have a 3D, okay, this is called a real plane. That means that the complex, which is the I, will not take form in this case. Okay. However, in this section 8.6, we will talk about complex plane. When we talk about complex plane, we will talk about the A plus BI form. Okay, so this is called a complex number. In this case, that A is called the real numbers, and then BI is called the imaginary numbers. So in order for us to figure out what is the complex plane here, then we will have to draw again like an X and Y. But in this case, your horizontal axis is the real. So this horizontal axis is the real. That means this part. And then the vertical axis is your imaginary. Okay, so this is the imaginary. So the absolute value of this complex number is the distance between your origin and the point AB. So for example, is if I want you to find what is the absolute value of A plus BI. So it's kind of like a magnitude in vectors. So you got the point A and B, where A in this case is the real and the B in this case is imaginary. And the distance is this one. This is what we call as the distance, the absolute value of A plus BI. Okay, so that is the distance between 0, 0 and the point AB. Okay, so in order for you to find this this distance, we use the Pythagorean theorem, which is the square root of A squared plus B squared. Okay, so you take the real, square it, take the complex, square it, and then you take the square root of it. So it's kind of like a distance formula here. So how do we graph this complex plane? It's very easy. So we look at some examples here. So plot. So question number 1 here. You have to plot 5 minus 12i in a complex plane and find the absolute value of it. So in this case, you just think this as your coordinates, but in this case, this is your real and this is your imaginary. So 5 in this case is the real one. So this is the 5 and negative 12 is the imaginary. This is negative 12. So this point, it's like coordinates point. So this point is what we call as 5 minus 12i. Okay, so this is how we graph or plot this in a complex plane. It's like coordinates. So instead of xy, it's real and imaginary. And now we need to find the absolute value or the distance. So we need to find what is distance for this. So in order for you to find the distance for this, you use this formula, square root of a squared, which is 5 squared, becomes 25, plus b squared. Now don't forget, when you square a negative number, it becomes positive. So 12 times 12 is 144. So this will give us 169. And if you take the square root of this, this is 13. So this is what we call as the absolute value of this. That means the distance from 0, 0 to this point. The absolute value or the distance is 13. You guys doing all right here? Questions with the complex plane? Pretty much simple, right? Okay. You have to be careful with this complex plane is because it's very similar to your trig trigonometry. This complex plane will break into 4 quadrants. Okay, so 1, 2, 3, 4. So if I give you like example number 1, this is in quadrant 4. Okay, and we still use your all students take calculus. You remember that that we learned in chapter 6 to figure out your tangent. Okay, so this is what we call as your complex plane. So this complex number or complex plane can be transformed from trig form to complex number. We call that as a polar form. Okay, so the trigonometric form of a complex number is we convert the a plus bi to become zr plus r cosine theta plus I sine theta. So this is what we call as a trigonometric form, or sometimes we call that as a polar form. How do you convert this complex number to a trigonometric form? Is your a in this case, because when you distribute, your a in this case will be r cosine theta, and your b in this case is your r sine theta. And r in this case is the square of a squared plus b squared, which is the same thing as what we call as a distance or the absolute value of it. And tangent theta in this case is b over a. Okay, this r that you see in the polar form or the trigonometric form is called the modulus, and the theta in the z in this of the z and the theta in this case is called the argument. So these are all just little definitions. But one thing I want to point out here, class, this is very important. I'm going to put stars here. Is when you find theta, be careful with quadrant. This is the one that a lot of students mess up, is you have to watch out for the quadrant. So what do I mean by that? Okay, example is this example that we have here. This example that we have here, we know this is in quadrant 4. So if you want to find theta, okay, so if you want to find theta in this case, in order for you to figure out theta here, let me just, so tangent theta in this case is taking B over A. B is your imaginary, A is your complex. So if you take B in this case is -12 and A is 5. And let's say that I want this in degree form, okay? So what you do here in your calculator is you move the tangent over. So this will become arctangent of -12 over 5. So I want everyone here to take out your calculator. Make sure this is in a degree form. So also be careful with what format they want. So in your homework, they can say, I want this in degree, I want this in radian mode. So make sure you know which mode. In the test, up to you. You want to put it in degree mode, is fine. Up to you in radian mode. So let's do this in degree mode so it's a bit more easier for you guys. So can someone tell me what is your theta in this case? Look at your calculator. Everyone do this. This is the one that a lot of students get wrong in your test. And it has a domino effect, means that if this theta is wrong, anything after you do that is gonna be wrong. Anyone got an answer here? Anyone? Hello?
I got like -67.38.
Yep, degrees, right? So this is -67.38 degrees. You guys okay here? This answer is wrong. Okay, so that's why I told you be careful in the test and in your written on your online homework. Whatever you came up in your calculator, yes, I also got -67.38 in my calculator. Now I'm going to explain why it's wrong, so please pay attention. The reason why is because this -67.38, if you want to draw this in your in this picture, the negative means that you go clockwise. So this is -67.38 that you find. And the reason why this is wrong is because your degree is usually measured in positive. So you are actually needs to find what is this orange one. So can someone tell me what is the degree in the orange one if the brown one is -67.38? Anyone?
Is it 292.62?
Yep, 292.62. And how do you get this answer here?
You just take 360 minus the 67.38.
That's correct. So so what you do here is if your complex the complex plane is in quadrant 4, you have to take 360 minus theta, like this case. Or if it's a radian, you have to take 2 pi minus theta if it's radian. What happens if it is in quadrant 2? In quadrant 2, we don't use 360, we use 180. So you're gonna do 180 minus pi minus theta, or pi minus theta if it's in radian form. Okay. And if in quadrant 1 is perfect, you do not need to worry because quadrant 1 everything is positive. You didn't worry about it. But what happens if it's in quadrant 3? Then you have to take 180 plus theta, or pi plus theta. So depends on what quadrant is your plane is your complex form a complex in the plane in the complex plane at. So make sure these are very important. So a lot of students make mistake in my test is because of this, and because of that everything is wrong. Okay, now so we can write this in a trigonometric form. by doing r times cosine theta plus sine theta I. Okay, or I sine theta. Let's do I sine theta. Again, the I can be is complex. This is called the trigonometric form, which is given here. R times cosine theta, right? Plus I sine theta. So this is the trigonometric form we're talking about here. So so R in this case is this the distance. This is your R. Okay. So, and then this is your theta. So if you want to write 5 minus 12i in a trigonometric form, your answer in this case will be 13 cosine of 292.62 degrees plus I sine 292.62 degrees. So this is how you write this in a trigonometric form if I give you 5 minus 12i. Now, because during the test, this is a long answer, right? Because you have to write this. So we can shortcut this. So there is a shortcut to write this trigonometric form. So instead of doing r cosine theta plus I sine theta, we will use as shortcut for this is r cis theta. So what is r cis theta is r is the r, the modulus. C in this case is cosine theta plus is means the I sine theta. Now you can use this to put it in my test, but please do not use this short form in your online homework. They will mark you wrong. So in your online homework, you have to type in this whole thing. But if you want to use the CIS in my test, then it will be written down as 13 CIS 292.62, which is the same thing as this, the whole long thing. Okay, so because in the test, you guys are running out of time, you don't have enough time to write all this. So we use a shortcut for that. You guys with me here? Okay, so make sure in the test I accept both of this. In your online homework, they only accept the long one. Okay. Questions in this case. So this is also can be written down as r cis theta. So let's take a look at number 2 here. So this is question 2 is given us by this 4 minus 4i. So I want you guys to draw this in the complex form, in the complex plane, and then tell me what quadrant it belongs to, and then write this in the trigonometric form, which is the CIS that I just did over here. Okay, so I want you guys to do question 2 here, which is very similar to what we did in here. So you have to draw the pictures. Tell me what quadrant it belongs to. Find the r, the modulus, and then find the theta, and be careful with the quadrant, and then write it in the CIS form. All right. Anyone know where is this 4 minus 4 root 3i belongs to? What quadrant? Anyone? Quadrant? Hello, class. Where is 4 minus 4 root 3i belongs to? This is your real, this is your imaginary. Nikita, Logan. So this, yep, quadrant 4. So somewhere around here. So that means that this is your 4. And then this is negative 4 root 3, right? So this is in quadrant 4. And now we need to find the R. So how do you find your R? Is you take the first one square and then you take the second one square. So when you square 4 is 16. And don't forget, it's always plus, not minus, always plus. I don't care about the sign. Now,
yeah, I have a quick question.
Faris?
How did we know that it's in quadrant 4?
This is your real, this is your imaginary. So your real is 4, your imaginary is negative 4 root 3. So
Okay.
quadrant
Okay.
4. Like coordinates.
Mm-hmm.
Okay. So to find the rate, the modulus, so we have to square this 4, which is 16, and you have to square this. Does anyone know how to do 4 root 3 if you square it? Anyone? Because this is the type of questions you get in my test. So this is the same thing as 4 squared times 3. Okay, so 4 in this case will receive the square. This 3, because the square and square root will cancel, you get 3. So this is actually is 16 times 3. So 16 times 3 is what? 48. And then add these two up. What's the addition of these two, anyone? This one should know. So add this becomes 64. And what is the square of 64? That is 8. So that means your R in this case is 8. Now you need to find your theta. So in this case, we use tangent because it's opposite over adjacent if you want to use a floor. So a tangent theta in this case is always the complex one over by the real one. So it's negative 4 root 3 over by 4. So it's always the complex one over by the real one. So this will cancel out. So you get negative root 3. And then you move the tangent in there. So become arctangent. So what is arctangent of negative root 3 in degrees? Anyone? Calculators, or you can use your unit circle. Where is arctangent of negative root 3?
Is it 120?
No.
Negative 60.
Negative 60. Very good. Again, negative 60 degrees is wrong because negative 60 is this, because it's go clockwise. But as I mentioned early on, I want this in a positive form. So can someone tell me what is theta in this case?
Is it 300?
300 degrees.
300. Yep, 300 degrees. Yep. Okay. So now you got your R, which is 8, and your theta is 300. Can you write this as a trigonometric form? You can use this if you want to. So R in this case is what? 8. CIS 300 degrees. So this is your answer in trigonometric form, because the question say you have to find the trigonometric form. This is a trigonometric form. And again, if you want to write this in your online homework, make sure you do this. 8 cosine 300 degrees, I sine 300, right? This is what your online homework will take. And also read the question carefully. If the theta can be in degree, And sometimes your theta can be in radian. So don't put 300 degrees if it's radian. Can someone tell me what is 300 degrees in radian? You should know this.
I think it's 5 pi over 3.
Yep, 5 pi over 3. So you just need to replace, if the question wants in radian, then you just need to replace this by 5 pi over 3. You guys okay? Questions? Tough? I will say not too difficult. And this is, again, very basic stuff. And if you need to know your basic stuff before we move on to the more complicated stuff. Okay. Now, 3, this is special. 12i. So what is your, you have to draw this complex. So this is first thing I always tell students is if you want to write this in a trigonometric form, you have to draw this graphically. Don't forget, this is your real and this is your imaginary. So can someone tell me where is 12i belongs to? Which quadrant? Anyone? Where is 12i?
Is it going to be on the y-axis?
Yes, above or below the y-axis?
Above.
Yep, so this is 12i. Okay, so it's like a y-intercept. Okay, it doesn't belong to the third quadrant, it's on the y-axis. Okay, so this is the y-axis. So what is so 12i is here. So what happens to your r? Your r is the distance from the 0, 0 to this. So this is your r. Can someone tell me what is the distance from here to here?
12.
12. Yep. You do not need to use, if you want to use the a squared plus b squared square root of it, you can, but if it's on the x or y axis, you do not actually need to use the formula because it's very straightforward. And theta is this one. This is theta, right? So can someone tell me what is theta in this case? What angle?
90 degrees.
Yep, 90 degrees. So I just want to point out to you guys that if your complex number is on the x or y axis, you do not need to apply the formula. You can, you will still get the same thing. So the trigonometric form in this case will be 12 CIS 90 degrees. You guys all right? So very straightforward. What happens if I ask you for this case, instead of 12i, I give you -7. So can someone tell me what is
-7i or -7?
just -7, no I. Where is -7 at in this? What is your r? What is your theta? And what is your trigonometric form? Anyone? Sorry. Anyone? Where's -7 at in this picture? Is this -7 is real or imaginary?
It's real.
So
So
where
it'd
is,
be on the x-axis on the left side.
yep. So this is -7. Okay. And what is the distance, the r, from here to -7? What is the r? It will be 7. And the theta is going from here to here. This is your theta. So what is your theta in this case?
180.
180 degrees. So what is your trigonometric form for this case?
7 CIS 180.
Okay, so make sure you know that if I just give you plain numbers like this, you just your answer is either on the x or the y axis, depends on is it complex or real. Okay, otherwise if you have both a plus bi, then it will be on the quadrant. Now next,
Wait, if you give us just a number like that, how would we know if it's real or imaginary?
because there's no I.
So okay. Oh, okay. Gotcha.
That's I.
Yeah.
That's the difference. Question 4, we do the opposite. So so what happened is in question 3 here is I give you the complex, you give it to me as a trigonometry. So now on question 4 and 5, I give you the trig, you give me the complex. Now this is easy. The reason why I say question 4 and 5 is easy is because if you want to change your trigonometric form here to your complex form, you just use your calculator. You distribute the 5 and then you use your calculator in this case. Okay. So no, not use your calculator. Use your unit circles. So we distribute your 5 in here. So this is how we change from trig to complex. So become 5 cosine 135 plus I 5 sine 135. So this is, you just simply distribute your 5 in there. And then what you do, class, is use your unit circle and tell me what is cosine 135 and what is sine 135 degrees. Anyone?
Negative square root 2 over 2 and square root 2 over 2.
This is negative root 2 over 2 and this is root 2 over 2. And then you just need to multiply this by 5 in this case. So your answer in this case will be negative 5 root 2 over 2 for the real one. And plus this one, you will get 5 root 2 over 2. But don't forget, you just need to put an I on it. And your I can be in the front or the back, doesn't matter. So this is how you change your trigonometric form into complex form, a plus bi, where you just need to use your unit circle to figure out what is cosine and sine of that number value, that's angles, and then you get your value here. Okay, and then you just need to graph this. Can someone tell me how you graph this? What quadrant is this belongs to?
Quadrant 2.
Because your real is negative and your imaginary is positive. So your is in quadrant 2. You guys all right here? Questions? So which one is easier? Definitely trig to complex is easier. You just need to distribute. You don't do all this crazy work. But complex to trig, you have to do a bit more work here. Anyone? All right. So then we got some rules here. So we're going to talk about some rules. So once you know how to convert this into trig to complex or complex to trig, then we have some rules. This is very important. So if you want to multiply or divide with 2 complex numbers, okay, so if you are multiplying and dividing with 2 complex numbers, so what we do here is, let's say that your Z1 is R1 cosine theta 1 plus I sine theta 1. And Z2 in this case is R2 cosine 2 plus I sine 2. So what happens when you multiply these two? So this is something I always tell students. You multiply your R1 and R2 together, okay? And then what happens to your theta is you add them, okay? So you take your R1 and R2, if for the modulus, the R, you multiply it, and for the theta, you add them. So this is what happens when you multiply two complex numbers. If you divide, so in order for you to divide your R2 and R1, Z1 and Z2, so what you do here is you take your R1 and you divide with your R2, but for your theta 1, you subtract it. Okay, so you're subtracting your theta 1, theta 2. So it's very similar to your exponents. So if you remember exponents, when you multiply, we add the exponents. When you divide, you subtract the exponents for your. So this is very similar. And when you, for this case, make sure you multiply your two modulus. And for divide, divide those two modulus. So this is how we multiply and divide your complex numbers. So, so this is back to question number 7. So, so in order for us to do question number 7, you need to ask yourself, are we multiplying or are we dividing here?
Multiplying.
So we are multiplying here. So what you need to do when you multiply these two, you just need to take your R1 multiplied by R2. And then your theta will be adding theta 1 plus theta 2. Okay, so what is R1 in this case? R1 is the first one. That will be 3/4. And what is theta 1? Theta 1 also is from the first one. It's going to be what? Pi/3. And then you look at R2. R2 in this case is the second one, which is 4. And the theta 2 in this case is 3 pi/4. So what you need to do, class, is multiply this, multiply the R and add the theta. So can someone tell me what is this when you multiply? This is 3. CIS, and what happens when you add this? Now this is when you use the ABC button because they are fractions. So anyone know what is 1/3 plus 3/4? So that will be 13/12. You guys all right? Easy or hard? So this is your answer for question 7. Number 8, we are dividing this because you're dividing here. So again, when you divide, your R1 and R2 will be divided, but your theta is subtract. Make sure you know it's theta 1 subtract minus theta 2, not the other way around. So can someone tell me what is your R1 in this case?
That'd be 3.
That'd be 3. And what is theta 1 in this case?
50 degrees.
And what is R2 in this case?
9.
And theta 2?
20 degrees.
So what we need to do here is we just multiply, divide this. So can someone tell me what is 3/9? This is
1/3.
1/3. And can someone tell me what is 50 take away 20 degrees? It will be 30. So this is your answer. Easy, right? Okay. Now, this is easy. The reason why 7, 8 is easy is because these are already in trigonometric form. Okay. So in order for you to apply this formula that we do here, this has to be in trig form. Okay. So what happens if this is in a complex form, means a plus bi? So like question number 9 and number 10. Since these are not the same as this because it is not in the trig form, this is in a complex form. So you have to change this into trig form first. Okay. In what we do here is we have to Zoe. I just want to point out to you, if a question is given us in radian form, then make sure your answer is in radian form. And if your question is given us in the degree form, then make sure your answer is in degree form. So do not change this into radian if it's degree, or degree to radian. So look at your question. So that's what I'm going to tell you. So the question is in radian form. Make sure your answer is in radian. Degree, make sure it's degree. Don't change it to using pi over 6 here. I think your online homework will mark you wrong. I still give you correct, okay? But I think your online homework is picky about that. So Zoe, what you opt out is good. So just be careful that what is the question, what form, what mode they give it to you, okay? Or degree or radian. Now, what happens if I call you to question 9 and 10 is because this is not in a trigonometric form. So what you need to do first is to convert all this. There are two. So you have to convert both of this into trigonometric form. And then once you convert this in a trigonometric form, you have to multiply or divide. Like number 9 is multiply, number 10 is divide. And then you got this when you multiply, divide. And then what you do next is you have to convert back into standard form. So don't forget, standard form conversion is very easy. You just multiply 3 cosine 3 pi over 12. And then 3 sine 3 pi over 12i. So this is how you perform question number 9 and number 10. So I'm gonna, first thing what you guys need to do is I'm gonna do number 10 because I don't have number 9, is a bit easy. So first thing is you have to convert 1 plus root 3i into the trigonometric form, and 6 minus 3i in trigonometric form. So this, let's do the first one. We will need first, you have to give me the picture of this. Tell me what quadrant and give me your R, give me your theta. So what is your R in this case? Oh, wait, what's the R? Where is this 1 plus root 3i located in your complex plane?
1 plus 3i is located in quadrant 1.
Quadrant 1, somewhere around there. So how do you find R here? Is the square root of what? A squared plus B squared. Where is A squared plus B squared? A squared is 1.
1.
B squared is what?
Just 3,
3. So what is this? Is
2. R is 2.
R is 2. Okay. In order for you to find theta, you have to do the arctangent of B over A. So it's arctangent of square root of 3. So what is the arctangent of root 3? because your b is root 3, a is 1, so this is root 3 over 1, which is the same thing as root 3. Anyone? What is arctangent of root 3?
Wait, why is it tangent? Could we use like cosine or sine, or is it only tangent?
Because it's TOA. Because
Oh,
this
okay.
is your x and this is your y. So we use your tangent here. It's a fixed, so we use tangent here for this case.
Should be equal to 60 degrees.
60 degrees. Is 60 degrees in quadrant 1?
Yes.
So that means you do not need to do any addition. Remember last time is in quadrant 3 or quadrant 4, you have to do some weird stuff. So this one, you do not need to. So what is your 1 plus root 3i in this case? In trigonometric form, 2 CIS 60 degrees. Now you guys have to do this on your own. You want to know what quadrant is 6 minus 3i is?
Quadrant 4.
So how you find your r? Anyone? Yuko?
I got, this is for question, the B, right?
The r.
Okay. I got 5.
How you get 5?
I did. I don't even, wait.
What's the formula here? Anyone? What's the formula?
6 squared minus 3 squared, or
No.
yeah.
What do I always say is about your modulus?
Oh, always plus.
Always plus. So it's 6 squared plus what?
3 squared. Or-
Which is what? Because again, if you want to put -3, this will become positive, right?
It's
So what do you get?
36 plus 9.
Which is
45.
Can you guys simplify root 45? It will be 3 root 5. So this is your r, 3 root 5. Anyone know how to find tan theta? Arctangent of what? This is very important, class. So in order for you to find r, is the square of a squared plus b squared, always plus. To find theta is the arctangent of what? B over A. So what is B over A in this case? B is,
-3,
and A is,
6.
so what is this going to be? Calculator.
They gave me -26.6.
Yep. Is this correct data?
No,
So what, how do you fix this?
um,
Can't you just add 360 to it?
Yes. So what is your theta in this case?
333, 333.4, 0.43, I guess.
So 333.4, somewhere around that.
Yeah, 333.4.
So can you write this in the form of trigonometric? R in this case is what?
3 square root of 5
I
CIS
CIS of what?
333.4. 333.4.
Yep. So now the first case is, this is, you need to know how to, this is very important class. This is so important that a lot of students miss this. Second, so this part A is to change this into your trigonometric form. Once you got your trigonometric form, then we can divide this. So what happens when you divide this two up? So this, you divide. But unfortunately, when you divide, they are not like terms. So you can write this as 2 over 3 root 5. The only thing you can do here is to rationalize it. So if you want to rationalize this, you just move the root 5 up here. And then you just need to multiply the 3 and 5, become 15. So this is the most you can do with this division, because they are not like terms. You cannot cancel. So you just need to, if you want, you can rationalize it. Otherwise, you can just leave it as 2 over 3 root 5. But what happens to your angles? What you say is about when you divide, what happens to your angles? Abdi, what you do? Abdi, you there? So what you do with these angles? Anyone? Abdi?
I don't really know.
What's the formula when you ask for dividing? What happens to your angles? You have to subtract now. So what you do with this tool, you subtract it, becomes 60 degrees subtracted by 333.4. What do you get? Abdi, what do you get?
You get -273.4.
Okay. Now, and again, we do not like this -273.4 because it is a negative angles. Can you tell me what is the coterminal angles for him? So this is -273.4. Do you guys know how you find your coterminal angles?
Is it 86.6?
So you add, yep, you add 360. So this, because we don't like negative angles, we always want everything in between 0 to 360. So this will become, is it Abdi? Will you say 81?
86.6.
Yep. So this is your division here is 2√5/15 CIS of 86.6. And the last thing we're going to do here is part C. So part C, you just need to change this trig form into complex form. So how do you change trigs into complex form is you take 2√5/15 times cosine of this 86.6 plus I 2√5/15 times sine 86.6. So take out your calculator and do this. You guys have to do this. So this is how we convert trig to complex. We just multiply it. So 2√5 divided by 15 times cosine of 86.6. What you guys got here? Nicholas? Danny?
Oh,
Okay, class, you guys better do this. This is not tough. It's all calculator work. Yep, Nick?
I got the -0.27. I think that's wrong though.
Yeah, this is not 2√5/15 times cosine. Make sure this is degree, not radian.
That's in degree.
Anyone? Can't even do this in your calculator. Can't say anything.
I got 0.0177.
Okay. And what is Yuko? What is the sine one?
Oh, I haven't put that one in my calculator yet. How do we do we have to put the I in the calculator? As
No,
well?
don't put I.
Oh, okay.
Just use
Well,
this one.
okay.
No I involved. Class, simple calculator questions here.
The second one is 0.2976
So 298.
or just 298. Yeah.
Yeah, like I'm not picky with decimals, but so this is what we call as your complex form. Questions? Yes, the formula that you see over on this page here is very important. So make sure you guys know when you multiply, divide, you do this. You multiply your r's, add your theta, you divide your r, you subtract your theta. Next, we have what we call as a power. So what is a power in this case? Power in this case means that you will take it to raise to a power, okay? So that means that if you have a z to the power of n, you take this whole trigonometric form and raise it to the power of n. So what happens is your r will be power of n, but your theta will be multiplied to it. So this is what we call as the De Moivre theorem. So De Moivre theorem means that it is being raised to the power of n. So again, this also has to be in trig form in order for you to do this De Moivre theorem, where you take r to the power of n, and then your theta will be multiplied by n in this case. And what happens if this is not in a trig form? If it's in a complex form, you have to change into trig form using the method that you learned early on, the r equals tell me the pictures and so on. And then you have to find where is the theta at using arctangent. Okay, so this is used when you have power, raised to the power. For example, like question 11. So you raise this to the power. Unfortunately, for question number 11, this is not a trigonometric form. This is actually a complex form. Okay, if it's a trigonometric form like number 12, then it's easy. You just need to power it and multiply. So in this case, this is a complex form. So you need to change the 2 plus 2i into trig form again. So majority of the work that you do here is you have to, if they are in a complex form, you have to do the trig form in order for you to apply the formula. So can someone tell me what quadrant is 2 plus 2i? And what is r and what is theta? So 2 plus 2i is in what quadrant?
Quadrant 1.
Quadrant 1.
Quadrant.
So what is r in this case?
It's 2 times the square root of 2, or to be the square root of 4 plus 4.
What's 4 plus
So-
4? Square root of what?
Square root of 8.
And
which
what is,
becomes 2 times the square root of 2.
yep. And theta, you do the arctangent of what? 2 over 2, because our b is 2, our a is 2. So anyone know what is arctangent of 1 is?
45.
Degrees, yep. So what is a trigonometric form here? Two root 2 CIS 45 degrees. But so once you get this into the trigonometric form, you have to make this to power 6. So this is where the theorem came. So what is the theorem says about the De Moivre theorem says is your r, you need to make it to the power 6. Your angle, you multiply by the 6th power. So this is the meaning of the De Moivre theorem is your r power n, in this case 6, and your theta in this case will be multiplied by n, which is 6 here. Anyone know what is 2 root 2 to the power of 6? You guys have a calculator, right? So 2 root 2 to the power of 6. Make sure you put parentheses on it, like what I did on here in your calculator.
16.
So no, it's not 16.
Is it 512?
Yeah, this is 512. Class, make sure you know how to use your calculator here. And what is 6 times 45?
270.
270. So this is your answer in this case is 512 CIS 27. And this theorem is called De Moivre theorem. Okay. And it only used when you take it to the power of something. Questions with the De Moivre theorem? And last one, this is the most difficult one. So this is the one that you see in your test, and also you will see in your review test too, is what we call as finding the nth root of a complex number. Okay. So in order for you to find the nth root, what's the meaning of the word nth root? Nth root is like zeros. Okay. So in order for you to find the nth root of a complex number, first thing first, you have to change the complex number into trigonometric function. Okay. Nth in this case, it can be a third root, fourth root, fifth root, sixth root, depends on your power. So if you're talking about x cubed, we are talking about the third root. If you're talking about x squared, second root, x4, fourth root. In order for you guys to figure out what is the formula to figure out what is this complex n root, the formula is given us by this. Yes, this is formula. Please, I think you guys can allow to use one page of notes, right? So this formula is used to find the nth root of a complex number, given that k in this case is 0, 1, 2, 3, 4. So what you need to do here with this complex, this formula here is the r in this case comes from your complex root r. Your theta in this case comes from the theta that you have from the trigonometric form. And you have to keep on adding 2 pi k. The reason why you have to keep on adding 2 pi k is because it goes revolutions here. And k in this case is depends on 0, 1, 2, 3. So this is what happens when you have let's say your n in this case is 3, which is a cube root in this case. Okay. So in this case, you have to substitute this equation, k becomes 0. And you will figure out what is z0 is. So that means your n in this case will be 3, and your k will be replaced by 0. So you will get like a RCIS something. Okay. And then you will replace k equals to 1. So you're looking for z1. So in this case, your n still 3 because we're doing cube root. And now you replace k is become 1. You will still get RCIS, an angle. And the last one we have to do is k is 2. So z2 in this case will be also RCIS, a number. So so when you have n is 3, you should have 3 answers where k is 0, 1, and 2. If n is 4, you should have 4 answers. So that means you will get z0, z1, z2, and z3, and so on. So this is what we call as your nth root of complex number. And yes, this formula, as you know, that is coming up in your test. So please make sure you know this, write down on your notes here, and then make sure you know how to apply it. So we're going to talk about this in the last 2 questions here. So this question is talking about this one. So x cubed minus 27. Okay, so this is x cubed minus 27. Let's do number 16. That's a bit more difficult. So 16 x4 plus 1 plus I equals to 0. So you need to find what is the solution for this. So in order for us to find the solution, you make x4 by itself. So x4 in this case will be -1 minus I. So you just move this to that side. So the 1 become negative and the I will become negative. So since we are using x4, so your n in this case will be 4. Okay. So the formula, as you mentioned, if I put it up there, is depends on the n here. So the n in this case is depends on what kind of power we have. So since this is a power 4, our n is 4. If it's a power 3, n is 3. Now we have to convert this into a trigonometric form. So we're going to go back to the same thing that we did on the rest of the questions. Where is -1, I located at? quadrant.
Quadrant 3.
Quadrant 3. So what is your R in this case? Square root of 1 square plus 1 square. Don't forget your A is 1, -1, and your B is also -1. So this is actually is square root of 2. Your theta in this case is the arctangent of what? -1 over -1. So we know -1 over -1 is 1. So anyone know what is arctan of 1 in this case?
Is it 45?
45 degrees. This is where students get wrong in my test, but 45 degrees is wrong. Because if you look at this, this is in quadrant 3. So this is what angle? I'm going to take attendance. Can you please put present in the chat room?
Is it
Oh, what?
225?
Yes, this is 225. Okay, because 45 degrees is this one, so you have to add 180. So this is 225. So this trigonometric form is actually is √2 CIS 225. So a lot of students get wrong in the test is because they think this is 45 degrees. So be careful with that. Okay. So once you get this into the CIS form, then we can use the formula. So the formula to find your nth root is given us by zk. Nth in this case is 3 and 4, sorry. N in this case is 4. The reason why your n is 4 is because, again, 4th here. So power 4. So 4th square root of r. And r in this case is your what? Square root of 2. So this r in this case is a √2. CIS theta plus 2 pi k over n, because this is the same thing, theta plus 2 pi k over n. And theta is the one that you found using the tangent here. That will be 225. Okay, so theta in this case will be 225. And n in this case will be 4, because our formula here says it's 4. So what we need to do here is, because you got 4, so in this case k has to be from 0, 1, 2, 3, because you will have 4 answers. Due to n is 4, you get 4 answers. So what we need to do here is we do k is 0 first. So when k is 0, z0. Does anyone know what happens when you take a 4th root times a square root? Fourth root times the square root. This is actually is the 8th root. So this is 4 times 2. So when you see a 4th root and the square root, this is actually is the 8th root of 2. CIS, now you replace k to become 0. So can someone tell me what is 225 plus 0 over 4? Because your k in this case is 0. Oh, I'm going to use 2 pi, I use 360, sorry. The reason why is because this is in degree. 2 pi is only used when you have radian. So I'm going to use 360k. Because we are in degree here. So since our k is 0, so 360 times 0 is still 0. So so if you take out your calculator, this is 225 divided by 4. So this is 56.25. So this is one answer. As you know that they got 4 answers because your power is 4. And now we need to find the second answer by replacing k is 1. So this is z1. So we're still gonna have the 8th root of 2. CIS of 225 plus, since my k is 1, so it's 360 over 4. So what you need to do here is take out your calculator and do what is 225 plus 360 and then divide it by 4. So this is gonna be 146.25 degrees. And you're gonna do this quite a few times, actually 4 times. Then you're gonna find when k is 2. So if we do z2, it's gonna be 8th root of 2, CIS of 225 plus, now you're gonna take k is 2. So 360 times 2 is 720. And this is over 4. Again, use your calculator, figure out what is 225 plus 720 divided by 4. So this came out to be 236.25. And then the last one is where k is 3. So we get z3 and it's an 8th root of 2. CIS, now you replace this k with 3. So it's 225 plus, what's 360 times 3? 1080 over 2. So this is 1080 plus 225 over 2 over 4. Sorry, not over 2, over 4. Over 4. So that will be 326.25. So what happens in this case that this answer for doing this question 16, you will have 4 answers because your power is 4. And in order for you to figure out what solution you have to use this formula, and the formula is the same as the formula I show you over here, the green one that I highlight. And we have to use this for 0, 1, 2, 3 because of 4 answers. So you have to replace your R is being replaced by the R that we found early on, and the theta is the one that we found using the trigonometric form. And you have to figure out what is your answer is by putting k is 0, 1, 2, and 3. So this is your answer. So if you want to do this graphically, you can do this graphically on your answers. The first you need to figure out what the radius here. So your radius in this case is 8th root of 2. Okay, and your first answer that you see here is 57.25. So your first answer in this case will have 57.25 here. So this is your first, this is when k is 0. Okay, when k is 1, you will still get the same same r, which is 8th root of 2, but this time the theta that you have here is 146.25. So this is your k is 1, your second answer. When k is 3 is 2, your radius is still going to be 8th root of 2, but then your theta is going to be 5 and 3, which is 236.25. And the last one is your radius is also 8th root 2, but this is going to be on 326.25 degrees. So this is what your answer looks like. It looks like a circle, but each one of these radius is determined by your angle here. So make sure you know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So it's not always break it in 4 quadrant. This is 4 quadrant is because you got 4 answers. So sometimes this one can be only found in quadrant 1, 2, and 4, or 1, 3, and 4. Depends on your answer you get in this here. So it's not necessary you have answer in 4 answer. So this is how you represent this answer graphically by using your the complex form. This is this is real, this is imaginary. So this is how we do this question 16, which is very similar to this question you are doing number 10 here. Okay, so this is given us that you in question 10 you are this is your review test. You are looking for a complex cube. So when I ask you for complex cube, what is my n in this case?
3.
3. So in this case, if I want to do this question for your review for the test here, your n in this case is 3. So I'm gonna So in this case, z is -√3 plus 4i. So since you are looking for a cube root in this case, your n is 3. So if your n is 3 means your k only have 3 choices, or we start from 0. So you only got 0, 1, 2. So you got 3 choices here. So now what you need to do, class, is look at this complex form. You have to figure out what is your r and what is your theta is and where is it belongs to. Can someone tell me what is this belongs to? Where's -2√3 plus 4i?
That's in quadrant 2.
Okay, this is in quadrant 2. So can someone tell me what is your r in this case? I'm going to cancel this so that you're not going to use this in degree in radian. I'm going to use this in degree. Okay, so this is in so in your test, I just want this in degree, so it's easy for you guys. So anyone? Okay, Jack, make sure you watch this video. Where's your r in this case? You have to square this fellow and square that fellow, right? So 4 square is easy, is 16. So make sure it's always add them. You want to know what is the square of this?
$12.
Yep. So this is 4 times 3, which is 12. And the 4 is 16. So what's 12 plus 16?
28.
28. Can you guys simplify root of 28?
2 times √7.
Yep, that's correct. And for arctangent, you have to take what? The b over a. So it will be 4 over by -2√3. And the 4 and the 2 can reduce because this is reduced to become 2. So take out your calculator. What is arctangent of -2 over √3? In degree. this is your test looks like. Anyone?
Mhm.
Negative 49.11.
But this negative 49.11 is wrong because it's right over here.
Is it 40.89?
40.81 is in quadrant 1. Don't forget, we want quadrant 2. So how you guys figure out quadrant 2 angles?
Isn't it 180 minus theta?
Yep. So you have to take 180 minus 49.11 because 49.11 is also here. So in order for you to find what is theta, which is this green one, you'll have to take 180 minus that. And what is theta in this case?
$130.89.
So it's 130.89 degrees. So what is this in the form of trigonometric form, the CIS form? Two root 7 CIS of 130.89 degrees. So this is just finding this complex to become trig form. Okay. And now we want to find the solutions or the zeros. So you have to use this formula here. Okay. And the formula says that ZK in this case is n. So n in this case is 3 square root of r CIS theta plus, again, we don't use 2 pi, we use 360 because this is all in degrees. K over by n. N in this case is 3. Okay. And the r and the theta is what you just found early on in your with your trig function here. So your r in this case will be 2 root 7. And your theta in this case is 130.89. Okay. So it's, I have no room, I just put it down here, it's 130.89. Now, sometimes students doesn't like this. So if you don't want to write this 2 root 7 here, you can also write before you take the root, which means square root of 28. It's just fine, I'm not picky. So now you need to find what when k is 0. So what happens when k is 0? So Z0 is equals to, now last time is a root 8 because 4 times 2 is 8. Now this time is 3 times 2, which is root 6 of 28. CIS of, now this k is 0, so you just take 130 divided by 89. So take out your calculator and figure what is this one out. And then you do the same thing for k is 1. So Z1 in this case is the 6th root of 28. CIS, now your k is 1. You just take 130.89 plus 360 divided by 3. And you will figure out what is your second one. And then the third one is you just repeat with 2. Z2 is same thing. but then you do 130.89 plus 2 times of 360, that was 720 over by 3. And you will get this. So don't forget, when n is 3, you will get 3 answers. And these are your answers here. Questions? This is how you do question number 10. Yes, you will get this in your test too on Monday or Wednesday. Make sure you use your calculator to figure this one out. This one, leave it at 6/28. Don't do anything with it. Okay. Questions? All right. We're gonna stop here. Don't forget your test is on next Monday or Wednesday. If you have any